constructor is a special type of method. A constructor is invoked upon instantiation of a class. In C#, these are known as instance constructors. Now, these types of constructors that get instantiated when you create an object are really used to initialize that object. Maybe you've got a set of data members that you want to populate, but you're waiting for the object to provide that information to you. A constructor is invoked when you use the new operator. If you're looking at a class definition, you should be able to locate a constructor pretty easily, because the name of the constructor must be the name of the class. So if you have a class called bank account, your constructor has to be called bank account. If you're coming from a Visual Basic.NET background, VB constructors are named something a little different. They use the keyword new to name their constructor. Let's take a look at a simple example of a constructor. I have an employee class here. It's a public class. And notice that I have 3 data members here. I have first name, last name, and department. Now remember that members of classes are by default declared as private. So these are implicitly declared as private data members. And we know what that means. That means that first name, last name, and department, these variables, are visible only within the class. Now notice down below I have 2 methods, but these are special methods. These are constructors. Now I know right away because constructors take on a special syntax. The first thing you'll see is that the constructor name is exactly the name of the class, and that's the way it's got to be. This constructor is called a zero-argument constructor. And when you create a class in Visual Studio.NET, this is the constructor you get. This is the default constructor. Notice what it's doing. It's actually taking some of your instance data and it's creating a value here. So what it's doing in theory is it's initializing your data members. That's the idea. So when this is called, remember this is called first, and it's called when you instantiate the object using the keyword new. What is happening here is the department variable is set equal to HR. So it's initializing some of your data for that particular object. So let's take a look at an example of creating an object from this employee class. If I create an object from this employee class, I name the type first, then the reference variable, the keyword new, that will create an instance of this employee class. This is a type of employee. Now notice to the right of the keyword new, this is a call to the employee's constructor. Now notice that it has no arguments, so it must be calling that default or no argument constructor. So when I instantiate an object, I am in fact calling the constructor, and I'm calling it right here. Now notice that my class has 2 constructors. This is a case where I've overloaded my constructors. Remember, method overloading means that I have 2 or more methods with the same name but different signatures. In this case, the parameter list is none, doesn't have any parameters. So this signature for that method is different than this signature for this method. This has no arguments, this has 3 arguments. So overloading constructors is a very, very common example of method overload. And that's what I've done here. What it presents is it presents the object with different ways of initializing its values. Notice in this first example, all I'm really doing is initializing department, and I'm kind of giving it a default value for every object, every employee object that's instantiated. Every employee object that gets instantiated is going to start out anyway, that object is going to start out life with the department variable equaling HR. In the next case, what I'm doing is I'm offering anyone who wants to create an employee object to offer a first name, last name, and department value so that I can initialize those within the constructor. Notice first name, last name, and department, those are your instance data members up here, are getting initialized. And they're getting initialized through the instantiation of an object. Let's take a look at that. Looks the same so far. But notice what we're going to do. We're actually going to include three parameters. I have a variable called X, which is of type employee. I'm creating a new employee, an employee object in memory, and I'm calling the 3-argument constructor. So what I'm really doing is I'm calling this constructor right here. What this does is it gives the object an opportunity to actually initialize some of the data members. Now notice that you could actually call one of two constructors. There are two constructors in this class, so I could have either called the employee no-argument constructor or the employee 3-argument constructor. Which one I call depends on the signature that I've used here. Notice I've used the signature that matches the 3-argument constructor, so in fact that's the one I'm calling. Now if you take a look at that 3-argument constructor, there's one more idea that we want to talk about, and that is the use of the keyword this. Let's take a look at the application of that keyword. Say, for example, I have this constructor. And let's say my parameter list, the names of my parameters exactly match the names of my data members. So somewhat common practice. Now, before we start, just take another look and notice that the parameter names are exactly the same as the data member names. So in theory, what I'm really saying is take the data member variable and set it equal to the first name parameter. But that's confusing. It's ambiguous. So what you can do is you can put the keyword this in front of first name. What this denotes is the current object. So it's a reference to the current object. What you're now saying is take the current object's fname data member and set it equal to the first name parameter. And you can do that all the way through. If I were to create an instance of the employee class, I now have two constructors to choose from. Right here is the call to the constructor. Now I have overloaded the constructors. So I have the choice between these two. I'm going to choose the 3-argument constructor. And that means my signature has to match. I have to provide this constructor with 3 string parameters. What will happen when I execute this line of code is that it will call the 3-argument constructor. It will look to see if any of its constructor matches this signature, and in fact I have one right here. So what I'm saying here is I'm saying take the current object's fname data member and set it equal to the fname parameter.